What's going on, everyone? Gary with your FCP Euro. Welcome back to another DIY video. Today we're going to show you how to carbon clean the intake valves on your 2011 BMW 135i. Even though we're going to be doing this on a 2011 BMW 135i, this job is going to apply to any BMW with the N55 engine. We do offer two different kits, one that includes the valve cover and one that allows you to do this job without the valve cover. If your vehicle has more than 100,000 miles on it and you're still in the original valve cover, it does make sense to pull the valve cover off and replace it at the same time because the valve cover is an emissions related component and does affect the amount of blow-by that makes it onto the back of the intake valves, which could come up. If the valve cover is relatively new, it might make sense to leave it on, especially if there's no leaks. So in that case, you're not going to be replacing this. And in our case, we're doing it the BMW approved way, which is using this feeler gauge tape to block off the ports that ventilate into the intake ports on the N55 cylinder head. And we're going to show you how to do it the BMW way, but we do have this other option if your vehicle's higher mileage. Unlike the N54 engine, which was the predecessor to the N55, the N55 does not suffer the same amount of carbon buildup on the back of the intake valves. And therefore, this is not something that's going to have to be done as often. However, if you have a vehicle that has more than 100,000 miles on it, and you are starting noticing some rough idling, perhaps some power loss, maybe some roughness that wasn't there before, it is worth taking a look and cleaning those intake valves, because any kind of blockage or any kind of buildup on those intake valves is going to interrupt the airflow into the engine, which on a direct injected car is absolutely going to cause some performance problems. So with that said, this car has well over 100,000 miles, actually 160,000 if I remember correctly. It's never been carbon cleaned. It's going to be very interesting to see what this looks like. And it is tuned with a bigger turbo on it and a whole bunch of other stuff. So it's going to be interesting to see what this one looks like. With that said, let's talk about some of the tools you're going to need to do this job, and then we can go ahead and jump right into it. A couple of the required tools for this job, if you're going to do it the BMW approved way using the abrasive blaster, first and foremost, you will need an air compressor. The bigger the air compressor, the larger the shop air supply that you have, the better this is going to be, because you are going to use a lot of compressed air during this job. That said, an abrasive blaster like this is what you're going to need in order to blast the carbon out of the inlet and the intake ports on the cylinder head. Along with that, this is the special vacuum adapter from BMW that sits in the cylinder head port, shop vac attached to this backside, and then this wand right here kind of goes in this hole, and then you can angle it and clean off the back of the intake valves and clean up the whole general area. So these three tools are required if you're going to be doing it with an abrasive. Of course, if you're going to do it the manual way and scrub it out, you wouldn't need these tools, but this makes the job go by a lot faster. So this is the BMW recommendation and our recommendation. And again, these tools are available for FCP Euro. Aside from the specialty tools that we talked about in order to do the carbon cleaning on the intake valves, some of the other items that you're going to need just to simply get access to the intake valves: your typical BMW socket sizes, E14, E18 for the cross brace that goes across the valve cover. You will need that out of the way to remove a bunch of electrical connectors, etc. 8mm, 10mm, 11mm for the intake manifold nuts, and then a 22mm socket for barring the engine over by hand. You also need a torque wrench that could do torque specs as low as 8.5 Newton meters and then up to 15 Newton meters, so an inch-pound torque wrench basically. Various ratchets, 6mm hose clamp driver. I use these little pry bars a lot for undoing electrical connectors. And then I also have these pliers on hand right here. I use these for compressing double lock connectors that are sometimes in a tight space and also getting a grip on some connectors as well. Electric ratchet will also help make the job go by a little bit easier. But with that said, these are the basic tools you're going to need to do this job, along with some of the specialty ones that we already talked about. Let's go ahead and jump into it, and we'll see what we got to do to get this done. All right, so in order to do the carbon clean, you need to be able to bar the engine over by hand in order to close the intake valves. Since this 135i has the DCT transmission, we need to come underneath the car and manually put the transmission into neutral. If you have a manual transmission car, obviously you could just leave it in neutral. Or if you happen to have a car that's automatic, depending on which automatic, there's going to be different ways in which you put it into neutral. It's going to be totally vehicle dependent. In the case of this DCT transmission, we need to push up on this mechanism here, and we're neutral. It's that simple. You could also do it from inside the car. However, that neutral mechanism is very, very fidgety on the non-M DCT transmission. So anytime you don't have to go in there and do it, it's best to push it by this mechanism here. So it's locked in neutral. We'll go ahead and lower the car back down, and we'll do everything we need to do in the engine bay now. One thing you might notice here is this car does not have the windshield cowl or the air filter tray in the back. That's a common modification a lot of people do on these E90 and E80 chassis cars, particularly if you're tuned and you think you're going to be replacing spark plugs a lot. People just tend to leave them off. With that said, up front, we have 4 T20 screws that we need to remove, which I'm going to do right now. This will allow us to take the suction cowl out of the way. From here, we can pull this portion of the suction cowl off, and unhook it from the airbox and pull it forward. There we go. We'll pop the forward portion of the engine cover off. I think BMW calls it beauty cover. And now from here, we need to get our engine airbox out of the way. A couple things to note. We have these cables in the back which hook onto the back side of the airbox, so we need to release those first. And then we have a 6mm hose clamp over here we need to loosen up, and then we'll be able to pull the airbox up and out of the way. So I'm going to start first by making sure nothing is connected to the airbox. It does not appear to be. Well, we have the bracket here, so we'll just pull these cables off. These are the cables I'm talking about. So we have a positive battery cable and some of the engine wiring harness. We'll just slip those up and off. I'll push those off to the side. And now from here we have our mass airflow sensor connector. Just using this little pry bar right here instead of a pick, just pushing up on the release. And then we'll slide it off. And then we have our 6mm hose clamp right here. We're going to loosen. And then from there, we can pull our airbox up off the grommets like so, and pull it off in one piece. We have some other components here on the engine that we will need to get out of the way. So, we have this additional wiring harness stuff that we'll want to kind of go ahead and pull back. And then we have this cover that goes over the top of the engine that we're also going to go ahead and remove. We need to take this reinforcement brace off for the strut tower. Simply turn this access hole like that. That'll gain us access to a big E-Torx bolt right there. And we're only going to remove this piece here. I'm not going to pull that bolt out entirely, just part of the way out in order to slide this out. The big bolt up top is an E16. And then our bolt here at the strut tower is an E14. The E14 strut tower bolt is going to come out entirely, and then we can just pull it out like that. Now that we have that cross brace out of the way, we can go ahead and remove this plastic cover. This car has an aftermarket intercooler piping. The factory pipe is plastic and very prone to breaking, particularly right here at the throttle body. So if you're doing this job, not a bad idea to have a spare inlet pipe on hand, or it'd also be a great opportunity to upgrade to a metal one that won't break. But this area, very, very fragile on the stock inlet pipes, particularly if it's never been removed before. First thing we're gonna do is we're gonna pull this clip up. We're actually gonna remove it entirely. And this inlet pipe is going to come off, no problem whatsoever. We have enough flexibility there because of the silicone couplers, but like I said, if you do have a factory inlet pipe, they've been known to break when you pull them off. So just be prepared for that. And we're gonna remove this upper coupler, which is just a 10mm drive, again, on a stock car that's gonna be slightly different. But the stock charge pipe is 2 pieces, and that'll just allow us to remove the pipe entirely, which is what we need in order to pull our intake manifold back. We also have another connector here that we need to undo. This is the T-MAP sensor. So at this point, we have enough room here and flexibility to start loosening up and removing all of the intake manifold hardware. It's all 11mm nuts, with the exception of our forward one here, which is a bolt, but 11mm drive still. So we're gonna go ahead and just remove these entirely. We do have another bolt, actually 2 bolts. So in this case, it's 2 bolts and 5 nuts. The vacuum line that comes over to the vacuum reservoir on our valve cover is directly in the way, which is awesome. So this is one of those quick disconnect style couplers. We need to squeeze the locking tabs, kind of rotate it, and then pull it up. These things are pretty failure prone, and they don't like to be messed with too much. So be very careful removing that connector. I like to use these hose pliers to squeeze the tabs, particularly when they're in tight spaces like this. If your N55 has a pneumatic wastegate, it is going to have this vacuum line. If it's an electronic wastegate, it will not have that vacuum line. So pneumatic versus electronic, just one extra thing to disconnect. And from there, we have enough flexibility in that line to remove the bolt. Moment of truth, we should be able to pull the intake manifold back and off the cylinder head. So we have the car back up in the air. We need to remove this splash shield from underneath the car. Clearly this is an aftermarket aluminum splash shield. Your factory plastic one can be held in with 8mm self-tapping screws pretty much exclusively. You might come across the odd 10mm. This is held in with 4mm Allens because of the fact it's aftermarket. It goes without saying that metal is heavier than plastic, so for the last handful of screws, make sure you have a good firm grip on it. The same would also go for the plastic under tray too. You don't want that coming down on you. We do have the intake manifold loose, but before we can go any further, we need to remove our fan. So on the CSF radiator, there's going to be a 10mm screw that secures the fan to the radiator. So we need to remove that first. On a stock car, it would be like a T25 self-tapping screw. So I'll pull this 10mm out over here. And then on the bottom, we have a T25 screw holding the transmission cooler to the fan shroud. All right, we need to disconnect a bunch of electrical connectors that go to the intake manifold. So for example, we have our evap purge line. We're gonna go ahead and disconnect that first, along with the evap purge hose. This again is one of these pinch style connectors, so probably going to be a little stubborn at first. Just need to work this one off. You wouldn't be able to see that on camera, but what I was doing is I just took these pliers, pinched the release mechanism, which is right here. And when the release mechanism was pinched like that, I just took this little pry bar, wedged it between it and what it seats against, and I was able to kind of leverage it down and out. This O-ring right here, the blue thing, is what seals it, and those can be sometimes very stubborn. I found that this method is usually the easiest way to release them. We have a couple of connectors up here on the intake manifold, so we have another map sensor right here. We'll go ahead and release this one. And we have this connector that sits in here. We have our high pressure fuel rail sensor back here, which the release mechanism is on the bottom side, so it's be tricky to disconnect. What I did here is I reached underneath, pushed the release, and then just used this little pry bar to push it off the sensor. I don't know what's going on with the throttle body connector. It is super tight, and I can't seem to get the lock mechanism to release. So my plan from here is going to be to disconnect the DME from the engine harness. The DME is attached to the intake manifold in these engines. And then that should give me enough slack to be able to sort of flip the intake manifold upside down, and then I'll actually be able to see the lock mechanism for that connector. We got a couple of these side lock connectors, and then we have a couple of these slide lock connectors. We're just gonna push down, and then we can slide the lock off like so, and then that will eject part of the harness. There's our vacuum supply line for the for the pneumatic wastegate, and now we do have one connector that's left over. I was having a super difficult time disconnecting, and that's for the throttle body. Normally those are not that difficult to remove. This one, for whatever reason, was being very stubborn. And now it's off. Let's go ahead and take a look at these valves. As far as we know, these have never been carbon cleaned. Got quite a bit of debris and nastiness in number one. Number two looks about the same. Number three looks pretty juicy. Number four, the valve actually looks a little bit wet. So maybe that's a little bit of a leaking valve stem seal, but I mean, you can see the carbon buildup through here all the way back to number six. So, I mean, this is not nearly as bad as what you'd see on an N54, but there's definitely enough there that would cause a interruption in intake flow and could cause a performance loss or some rough running. So looking here on the number two, you'll see this opening in the cylinder head wall. That is a vent port, and each one of these inlets has one of those vent ports that comes from the valve cover. We need to block those off. That's one major difference between the N54 and the N55. N54s did not have this additional ventilation port, and that's one extra step that we need to do in order to start cleaning these valves. So we said at the beginning of this DIY video that we were going to do this the BMW way, which is sliding a piece of feeler gauge tape between the valve cover and the cylinder head. I want to show you what that looks like and why you have to do that on the N55. The N55 engine does something called forced induction crankcase ventilation and then natural aspiration crankcase ventilation. That is a change over the N54 to reduce carbon buildup in the cylinder head. If you look here on the intake side, we have this feature on the valve cover. And if you look in the casting of the cylinder head, you'll see these channels that come down to each intake port. What we're going to do is we're going to loosen up the valve cover bolts on the intake side, starting from the front, going all the way down the side to the back. That'll allow us to slide this piece of feeler gauge tape underneath between the valve cover and the cylinder head. And that's going to block off one of those ventilation ports. So if I pop off the valve cover here, you'll see where that piece of feeler gauge tape is sitting. That feeler gauge tape is sitting directly over one of these ventilation ports. So that's a ventilation port, that's a ventilation port, that's a ventilation port, ventilation port, ventilation port, ventilation port. Didn't know I could say ventilation port 6 times without tripping myself up. But the whole point of the feeler gauge tape is to literally block every single one of these ports off. And the reason you want to do that is that when we have the vacuum adapter on here and we have the wand and we're blasting the abrasive material in here, we do not want that material working its way up into the valve cover. And you can see those ports right here. If we were to do that, we would essentially be replacing the valve cover at that point, because later on when the crankcase ventilates via the valve cover, it's going to drop all of that particulate back into the inlet, and then the engine's going to ingest it, and chances are if you have an abrasive material inside of an internal combustion engine, bad things are going to happen. So we want to make sure that doesn't happen, and this procedure allows us to leave the valve cover on, block those ports off, and prevent that from happening. But like we said at the beginning of this video, if the car has more than 100,000 miles on it and the valve cover is original, you probably want to replace the valve cover during this job anyway, which in that case, you could simply just block these ports off and then blast air back down the port to make sure none of that abrasive material is still stuck in that channel. But we know that this car has a relatively new valve cover on it, so we're going to do it the BMW way. I'm going to come down the side of the valve cover here. It's all E10 bolts. I'm just going to go ahead and loosen these a little bit. And then I'm going to slide the feeler gauge tape underneath. So at this point, we've blocked off all of those secondary ports with the feeler gauge tape. And now I'm going to start the walnut blasting procedure on cylinder 3, just because it's the easiest for our camera operator to see, but this is gonna be the exact same process all the way down the line. The valves are currently open, so I'm gonna rotate the engine clockwise with a 22mm socket on the crank. I'm gonna wait for those valves to close. Spark plugs are still in, so there's some resistance. And right there, the valves are closed. We have our vacuum here and the vacuum adapter. The vacuum adapter just goes onto a normal shop hose like that, and then we'll go ahead and take that and install it onto our intake port like so. Very simple, fits nice and snug. That'll allow us to go in there with the wand, which we have right here on our media blaster. And we'll kind of come in on the back side, there's a hole there, and we'll just kind of working around, move it up and down. We'll change the angle on it, and that'll allow us to get every single spot within that inlet port to clean all of that gunky material out of it. So this is cylinder 3 after the carbon cleaning. You can see all of the gunk is off the back side of the valves, also off the valve stem, and everywhere around the inlet. It's all been cleaned away. Didn't really take that much effort. Obviously, the abrasive is going to do most of that work. There will sometimes be a couple little pieces of shell around that just didn't get cleaned out. So you want to make sure that you remove all that material before you go on to the next cylinder. That is now totally clean, so now we can go ahead and move on and do the other 5. And doing the other 5 is exactly the same as what we just did on cylinder number 3. So at this point, all of the intake valves have been cleaned. I would say we used around 6 to 7 pounds of those walnut shells. We do include 10 pounds with the kit. So at this point, we're going to go ahead and pull our feeler gauges out. We don't need these anymore. Did label these with some yellow tape, just as a reminder later on to pull them out. And we're going to go ahead and tighten down those valve cover bolts again. We'll torque those to spec. So at this point, we'll go ahead and pull out the intake manifold gaskets. While these things are still very pliable and I'm sure they would reseal, it would be really unfortunate to do all this work to then, you know, have an intake manifold gasket leak or a lean fault because we didn't replace them. And these are pretty cheap anyway, so it's not really a need at this point to not replace them, so we're just gonna pop some new ones in. And now at this point, we're gonna go ahead and slide the intake manifold back in. I'm gonna leave everything loose and I'm just gonna start plugging in connectors. And then once all the connectors are plugged in, we'll be able to go ahead and torque it down to spec. Fortunately, most of these connectors, they are just going to plug in. Only on the DME connectors do we have to make sure that they're locked. Everything else, pretty much for the most part, is just going to click into place. So we're just going to listen for the clicks, which is our indication that it has locked. All the connectors are plugged in, and at this point we can start reinstalling our intake manifold nuts and torquing the intake manifold back to the cylinder head. All right, so at this point, I'm gonna go ahead and tighten the intake manifold down. Just gonna bottom out the nuts. Final torque will be 15 Newton meters, and they are 11 millimeter. And I'm just starting from the inside, working my way out. So now that the intake manifold is reattached to the cylinder head and resealed, I'm gonna go ahead and reconnect our inlet pipe to the throttle body. Obviously, again, this is an aftermarket charge pipe, so the installation procedure is slightly different because it has some flexibility that the factory pipe would not have. Best practice when installing any of these charge pipes, whether aftermarket or factory, is to leave the clamped connections loose first. Get everything aligned up at both the intercooler and the throttle body first. Once the charge pipe is secured on the throttle body and the intercooler, you can then go ahead and tighten all of the clamped connections down afterwards. So don't tighten those first, get everything situated, and then go ahead and tighten everything down. Also, best practice to also install a new O-ring on the charge pipe connection at the throttle body. Those do tend to leak after a while, so it is the best idea to replace them at this point. There we go, that is secure. At this point, we can connect our sensor down here for that click. And again, like I said, I left all these clamped connections loose so I can get the proper orientation on them. And now that everything is lined up the way that it needs to be, I can go ahead and tighten those down. Went ahead and reinstalled the vacuum line for the wastegate actuator boost reservoir. It's only going to be on early production M55s because they eventually moved over to an electronic wastegate, but this has a pneumatic wastegate, so just need to make sure that's plugged back in, which we just did. So at this point, I'm going to go ahead and slide the fan back in. And the key on this, by the way, so because this car has the CSF intercooler and the CSF radiator, the CSF intercooler has little hooks on it for a different sized radiator fan. This one extends all the way down below the intercooler, so this has a tendency to get hung up while I'm sliding it into place. And if it does get hung up, it's always because of those little brackets down there. And then the CSF radiator uses a 10mm bolt. Factory radiators use a T25, so that's really the only difference there. And then on your automatic transmission cars or dual clutch transmission cars, you need to resecure the trans cooler back to the fan shroud, which is held in with a T25 screw. So now we're going to go ahead and put the under tray back on. Again, this is an aftermarket tray. And it's just secured with a bunch of 4mm Allens. Your factory trays are going to be secured with a bunch of 8mm 6-points. All right, so at this point, we're ready to button up the rest of the engine. We're going to put the covers back on, put the cross brace back in, make sure the wiring is routed correctly and everything, put the air box back in, make sure all the connectors are plugged back in, and yeah, we should be good from this point forward. Next up, we'll stick the air box back in. A bunch of the wiring harness for the engine sits on this back side here, so I just want to make sure that those are resecured before I go too much further. And then we're going to take a 6mm hose clamp driver or a flathead screwdriver or a 6mm socket, tighten down this hose clamp here. Take our strut brace, make sure it slides under the main mounting bolt here at the back of the cowl. This bolt does have a torque spec at the firewall. However, we did previously mention that bolt had been stripped out previously and we did a thread repair on it. Do not trust that to hold the torque that it needs to be. So we'll tell you what the torque is, but I'm gonna just go ahead and tighten this down by hand to prevent any further damage. And then we have a E14 over here at the strut tower. We'll put the front of the engine cover back on. We'll reinstall the suction cowl here. This is at the front of the airbox. It just kind of clicks onto the airbox like so. And then we have these two pieces here that sit at the front of the crash structure. They're both side specific. And then those are secured with some T25 screws. So that's how you go about cleaning your intake valves on an N55 powered BMW. Of course, intake manifold has to come out of the way. The DME is attached to the intake manifold. There's a lot of connectors underneath the intake manifold you have to take care of. And also, depending on the chassis, some are going to have a little bit more room than others. At least in the case of this E-chassis car, the intake manifold is pretty easy to get out of the way. If you were doing this on, let's say, an F15 X5 where the engine sits in a little bit deeper, it might be a little bit more effort to get the intake manifold out of there. But the overall process is very easy, particularly when you have the air compressor, the media blaster, the vacuum adapter. Realistically, I don't see anybody being able to do this job unless you have those tools. So unless you have a big air compressor at home, this might be a job that you might not be able to take on if you don't have that preliminary equipment. But past that, very straightforward process. Just make sure you block off those ventilation ports in the cylinder head. Make sure all of the media is cleared after you've done the job. And also make sure the valves are closed when you're blasting the intake valves on any particular cylinder. You don't want to get any of that material inside of the combustion chamber. But hope you learned a lot in this video. If you have any questions or comments, leave them in the comment box below. If you like this video, hit the like button. Also, you're going to want to hit subscribe. We have a lot of content on the way. And as always, we'll see you for the next one. Thanks for watching.